ઇલેક્ટ્રિકલ એક્ઝામ પ્રિપેરેશન ચેનલની અંદર છે દર્શક મિત્રો, તમારું સ્વાગત છે. આ ચેનલને છે સબસ્ક્રાઈબ, શેર અને લાઇક કરવા વિનંતી. આ ચેનલની અંદર છે તમને પાવર સિસ્ટમ, ઇન્સ્ટ્રુમેન્ટ્સ એન્ડ મેઝરમેન્ટ, પાવર જનરેશન, ઇકોનોમિક્સ ઓફ પાવર જનરેશન, ઇલેક્ટ્રિકલ બેઝિક્સ અને ઓલ ટાઈપ્સ ઓફ MCQના વિડીયો છે એ મળશે. MCQ આ વિડીયોની અંદર આપણે MCQ ઓન ટ્રાન્સમિશન એન્ડ ડિસ્ટ્રીબ્યુશન વિશે ડિસ્કસ કરીશું. ટ્રાન્સમિશન એન્ડ ડિસ્ટ્રીબ્યુશન. Length of the cable is doubled. Its capacitance C will be double. Lengths of the cables and the capacitance of the cables are directly proportional to each other. So, if when we increase the length of the cable, capacitance also increase. Hence, if the lengths get double, then the capacitance also can be doubled. What should be the minimum depth of cable trench to duct for a layings of 1.1 kV cable? Depth of the trench for 1.1 kV cable 0.75 meter. Galvanized steel is generally used as stray wire, earth wire, structural components. Answer is D, all of the above. If the wires are made up with some other ordinary steels, rust and corrosions attack the wire after some time due to the environmental wet condition. A layer of zinc oxide can be provided on the steel wire by some chemical process. This zinc oxide layer protects the steel wire from the rust and corrosion effects. That's why galvanized steel is used in many places. Objective of electrical power transmission is R. A. Transmission system must be more efficient with minimum line losses. Voltage regulations of transmission line must be 0 or minimum. C. Both 1 or 2. D. Neither 1 or not 2. Answer is both 1 and 2. Now we can discuss the objectives of electrical power transmission. First, transmission system must be more efficient with minimum line losses and maximum power transfer capability. Second, voltage regulations of the transmission line must be 0 or minimum. Fifth, advantage of higher transmission voltage. What is the advantage of a higher transmission voltage? Answer, we can see that answer is D. So we can read the MCQ. First, A. Power transfer capability of the transmission line is increased if the higher voltage transmission is we used higher voltage for transmission. Transmission capability, transfer capability of transmission line is increased. Transmission line losses are reduced. Area of cross sectional and volume of the conductor required is reduced. Now we can discuss the advantages of higher transmission voltage. Power transfer capability of transmission line is increased. P-max, P is power, Vs is equal to sending in voltage and Vr is equal to receiving in voltage, and Xs is sending in reactance. Now if we increase the voltage, Vs is equal to supply voltage, Vr is equal to receiving in voltage. If sending in voltage is equal to receiving in voltage, now the P-max is equal to P-max chale se Vs square. So if we increase the voltage, so power transfer capability increase. Second, transmission line losses are reduced. Power P is equal to Vi cos phi. Now I is equal to P under root P by V cos phi. Transmission line losses Pi is equal to I square R. Therefore, transmission line losses Pi chale se 1 upon V square. When V is increased, then P means transmission line losses is decreased. Third, area of cross sectional and volume of conductor is reduced. Resistance R chale se R is equal to rho L upon A, where rho is equal to resistivity, L is equal to length of the conductor, A is equal to area of cross section. Therefore, area is equal to area chale se 1 upon V square. When V is equal to voltage is increased, then the area of conductor required for transmission is also reduced. Which of the following statement is true? At higher voltage, cost of transmission will reduce. We see that in MCQ that okay, when we increase the voltage of transmission line, then the cost of transmission is reduced. Answer is A. At higher voltage, cost of transmission is reduced. At higher voltage, volume of conductor is reduced. Area of conductor HLS 1 upon Vs square, where Vs is equal to supply voltage, so that the material requirement is reduced, hence the cost of the materials and transmission is reduced. 7th, maximum power transfer capability of transmission line can be increased by. There are some methods to increase the transfer capability of transmission line. Parallel transmission lines, using a series capacitance and using a bundle conductor. There are all three are answer of this MCQ. Maximum power transfer, P-Max એટલે કે maximum power transfer ચલે છે Vs square upon X, where Vs is equal to voltage, sending in voltage, and X is equal to sending in reactance. For a maximum power transfer capability of transmission line, we can be increased by either increasing the voltage level or reducing the line reactance value. Methods of reducing the line reactance. We can increase the maximum power transfer capability by increasing the value of Vs or decreasing the value of line reactance. And value of line reactance can be reduced by parallel transmission line, using series capacitance, and using a bundle conductor. For a flat voltage profile system, voltage regulation is 0%. Percentage voltage regulation, formula of percentage voltage regulation is a Vs minus Vr na sigma Vr cross 100, where Vs is equal to supply voltage, Vr is equal to receiving voltage. For flat voltage profile, receiving voltage and sending in voltage are equal, so that voltage regulation for flat voltage profile system is 0%. Maximum power transfer in transmission line can be obtained by increasing the voltage level or reducing the reactance. We see that in MCQ that line reactance, by reducing the line reactance we can increase the power. So in this MCQ, answer is C, increasing the voltage level or reducing the line reactance. Maximum power transfer P-Max चले से Vs square upon X, where Vs is equal to supply voltage, X is equal to reactance. Maximum power transfer capability of transmission line can be increased by either increasing the voltage levels or reducing the line reactance value. Methods of reducing the line reactance are parallel transmission line, using a series capacitance, or using a bundle conductor. Ferranti effect will not occur in which of following transmission line? Ferranti effect occurred in long transmission line, medium transmission line, but not occurred on short transmission line. When receiving in voltage, what is the Ferranti effect? When receiving in voltage is more than the supply voltage, means sending in voltage, then the effect is called as a Ferranti effect. Ferranti effect occur in case of no load or light load condition of medium and long transmission line due to the effect of capacitance. There are no effect of capacitance on short transmission line. In case of short transmission line, the capacitance effect is negligible. Therefore, Ferranti effect will not occur in short transmission lines. Which of the following methods are used for reactive or voltage compensation? એટલે કે reactive power na compensation or a voltage compensation. Which method is used? There are three methods are given in MCQ, which are true. Answer is D, all of above. Shunt capacitor, series capacitor, generation, excitation control, and for more method we can see hint. Voltage or reactive power compensation can be done in two ways. First way is by sending in method, and second is a generation excitation. In sending in and receiving in method. In sending in method, there are one method which is used to which is used for reactive or voltage compensation, generation excitation control, and in the receiving in method, shunt capacitor, series capacitor, shunt reactor, synchronous phase modifier, on-load tape changing transformer, and booster transformer are used for compensations or reactive power or voltage. Ferranti effect can be compensated by which of the following? Answer is shunt reactor. Ferranti effect occur in case of no load or light load condition of a medium and long transmission line. Due to the capacitance effect of a transmission line, therefore shunt reactor is used for compensating the Ferranti effect. Shunt reactor will reduce the effect of capacitance, therefore Ferranti effect will be reduced. Stability of transmission line can be increased by, answer is D, shunt capacitor and series capacitor. Stability of transmission line can be increased by shunt capacitor or series capacitor. Now we see the hint. Power P is equal to Vs cross Vr na sigma xs cross sin delta, where delta is equal to phase angle, Vs is equal to sending in voltage, Vr is equal to receiving in voltage, and xs is line reactance. If Vs is equal to Vr means sending in voltage is equal to receiving in voltage, then our formula is become P is equal to Vs square upon xs cross sin delta, where Vs is equal to supply voltage, Vr is equal to receiving voltage, xs is equal to reactance, and delta is equal to load angle. For constant power, if xs is more, load angle will increase and vice versa. Stability of system is more if load angle decrease. Load angle is decreased, then stability of transmission line is increased. Therefore, stability of transmission line can be increased by both shunt capacitors or series capacitor, but not shunt reactor. Which of the following method is used for changing the power factor from leading to lagging? Leading to lagging power factor changed કરવા માટે shunt reactor से use થાય. Shunt reactor is used for changing power factor from leading to lagging. Under no load condition or light load condition, medium and long transmission line may operate at leading power factor due to the capacitance effect. This leading power factor can be changed to lagging power factor by using of a shunt reactor. By using of shunt reactor, it will be compensate the effect of capacitance and changes the power factor from leading to lagging. Under overexcitations, synchronous phase modifier overexcitations, synchronous phase modifier works as a shunt capacitor. What is a synchronous phase modifier? Synchronous phase modifier is basically a synchronous motor operating under no load, and by adjusting the excitations, it is used for controlling the reactive power so that power factor and voltage are controlled. If synchronous phase modifier used under overexcitation is work similar to a shunt capacitor, delivering a reactive power and absorbing leading reactive power. If synchronous phase modifier is used as under excitation, it works similar to shunt reactor, which absorbs the lagging reactive power and delivers leading reactive power. This is used for compensating of Ferranti effect. Which of the following are the advantages of synchronous phase modifier over a shunt compensation? Answer is D, both 1 and 2. What is a single unit can be used as both capacitance and inductor by adjusting the excitation. In synchronous phase modifier, only single unit is used as a both capacitance and inductor. Smooth voltage regulation is possible by controlling the excitation. What is the benefit or advantages of the synchronous phase modifier? First, single unit can be used as both capacitance and inductor by adjusting the excitations. Smooth voltage regulation is possible by controlling the excitation. initial cost of synchronous phase modifier is higher. It consumes both active and reactive power. It requires more maintenance because of running equipment. It requires starting mechanism for bringing the synchronous motor up to the synchronous speed. Underexcited. Synchronous phase modifier works as we see that in a MCQ that when a synchronous phase modifier is overexcited, it is worked as a shunt capacitor. In this MCQ, synchronous phase modifier is underexcited, so it is worked as a shunt reactor. Advantages of shunt compensation. What is the advantages of shunt compensation? Answer is C. It requires less maintenance. Now we see more advantages of shunt compensation. Two separate units are required, inductors and capacitor. Step by step voltage regulation is possible. Cost of shunt compensation is low. It consumes only reactive power. It requires less maintenance because there is no running equipment. It does not require starting mechanism. Specify quantity of load bus R. This is the most IMP MCQ which is asked in many exams. Answer is A, P and Q, and this heat is very IMP. There are many MCQ available on this heat. Now we can study this hint. Load buses is known as PQ buses. Load bus is related to consumer requirement in which P and Q are known and specified quantities. For supplying these quantities, delta and V are to be calculated. Active power, reactive power, P and Q, phase angle and voltage magnitude are to be calculated. In load bus, P and Q are specified or known quantity and delta and V are calculated. Load bus, known quantity P and Q, unknown quantity V and delta. Generator bus, in generator bus, known quantity P and V, which is also known as a PV bus, and unknown quantities Q and delta. And the last bus, slack bus or reference bus, which is a known quantity V and delta, unknown quantities P and Q, where P is active power, Q is reactive power, V voltage, and delta is equal to load angle. Now same MCQ. Specify quantity for slack bus or reference bus, V and delta, which is specified, and P and Q are calculated in slack bus. Thank you for watching this video. For more videos, please subscribe, share and like this channel.